Let's build a histogram. So here we have a data set of the food services from Cedar Amusement Park. And they took a sample of 40 families who visited the park yesterday, and they've revealed that the families spent the following amounts. So here is our raw data. Okay, notice that this raw data, based on this, we can't really even clearly see where the lowest, the smallest and the largest observation are. I know that 18 is the smallest and 84 is the largest. So the first thing we want to do is we want to put this in kind of an ascending order to make it easy for us to create our distribution. Okay, here's our data now in ascending order. So you could see 18 and then 26, etc., all the way up to 84. Now we can work with this data. So what do we know so far? We know that n is equal to 40. We have 40 observations. So let's first start with step 1. And recall that step 1 is to figure out the number of classes. And we use the 2 to the k rule. 2 to k must be greater than n. So let's test this out. Let's try a few. So if we do 2 to the third, for example, we get 8. Well, that's not enough. 2 to the fourth, 16. Again, not enough. How about 2 to the sixth? Well, 2 to the sixth is going to be 64. And therefore, in this case, we will have 6 classes. Okay, so let's use our 6 classes. All right, so classes. We'll have 1, 2, 3, 4, 5, and 6. Next, we need to figure out how big each class is. We'll call these bins. So the bin is based on the interval. And recall that the interval must be greater than or equal to the largest number minus the smallest divided by the number of classes in our data set. So in our case, our highest number was 84, our lowest was 18, and we have 6 classes in this case. And so once we solve this, the interval must be greater than or equal to 11. Remember, you cannot round down the interval, okay? We can round up the interval. But for this purpose, let's just keep it at 11. Let's simplify it. On to step 3. So step 3 is to basically create our bins and establish the lower range of our data. So we know that our lowest number is 18. If we're keeping the interval at 11 and not rounding it up, then we should keep the first value in our first bin exactly the same as our minimum. So our first bin will be 18, an interval of 11, so plus 11 through 29. The second one will be 29 through 40, 40 through 51, 51 through 62, 62 to 73, and 73 through 84. Now this works out perfectly as this fits all of our data. To help us fill out the rest of this chart, I'm going to bring back in our data set that is sorted. All right, so let's start counting up the frequency in each class. So in class 1, 18 through 29, we notice we have 1, 2 observations, so the frequency is 2. In 29 through 40, we have 1, 2, 3 observations. In class 3, 40 to 51, we have 1, 2, 3, 4, 5, 6 observations. Now notice, we do have 51 in our data set. However, this 51 is effectively the start of class 4. So let's count the observations in class 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 observations in class 4. In class 5, 60 through 73, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And finally, in our last class, we have 1, 2, 3 observations. So here's our frequency distribution. Let's create a relative frequency distribution as well. Okay, actually, let's make it into a relative percentage of frequency. So to do that, remember, for the first class, we would do 2 divided by 40, which is the number of observations, times 100, and that would be equal to 5%. Class 2 would be 7.5%. Class 3 would be 15%. Class 4 would be 40%. Class 5 would be 25%. And finally, Class 6 would be 7.5%. Okay, so we can see that our most frequent amount of dollars spent at the amusement park on food by a family of 4 was between $51 and $62. Now let's turn this into a histogram. So here's our frequency distribution, and let's fill in our histogram using that data. So first, our first class, 18 through 29, has 2 observations. So let's go 2. Okay, you'll notice how I've labeled the frequency here for 8, 12, 16. You just have to come up with something that makes some sense and looks fairly good. Group 2 has 3 observations. Group 3 has 6 observations. Group 4 has 16 observations, clearly our biggest grouping. 5 has 10 observations, and 6 has 3 observations. So here is our histogram. For our data set. Now again, let's do our SOCS. Is this skewed or symmetrical? It's clearly skewed. It's not symmetrical, otherwise both sides of the distribution or around the center would be exactly the same. Is there any outliers? No, there's not. The center is clearly somewhere between 51 and 62, and the spread of the distribution is fairly closely clustered around the center. Clustered near center. All right, well that fits the criteria of our needs, and it just shows us that if we were to not see any of the data and just saw this picture, you can clearly state that most of the families are spending between $51 and $62 at the amusement park. Let's go on now and build a frequency polygon. All right, so in building our frequency polygon, we're going to have to calculate the midpoint of each class, and then everything else will be effectively the same as the histogram. So for the first class, to get the midpoint, we would just do 18 plus 29 and divided by 2, and that would be 23.5. From there on, we just add 11 to each one, and we get 34.5 is the midpoint of class 2, 45.5, 56.5, 67.5, and 78.5. And then we plot the frequencies along with that. You'll notice that I labeled the y-axis exactly the same way that I labeled it for our histogram, and of course I labeled the x-axis with the midpoints. So let's go in and put in our dots. So the first class has 2 observations. There's our first point. Second class has 3, slightly above that. Third class has 6. Fourth class has 16. Fifth class has 10. Sixth class has 3. Okay, so let's connect these dots. We'll just start it here. And here's our frequency polygon. So here again, you can see the same things we saw in our histogram. The center and the most frequent data is in our fourth class, with the midpoint representing the bin of 51 through 62. Now let's get to our cumulative frequency distribution. All right, let's build our cumulative frequency distribution. So now, in this case, the classes, remember, are similar to the bins that we had before, except they're going to be represented by the words less than whatever the upper limit is of each class. So our first class will be less than 29. Our second class will be less than 40. Our third class will be less than 51. Fourth class will be less than 62. Fifth class will be less than 73. And the sixth class will be less than 84. So those words are met in each of those classes. So how many of our observations were less than 29? Well, we had 2 observations that were less than 29. Now, how many observations are less than 40? Well, we have the 2 that are less than 29 plus the 3 that are between 29 and 40. So we have 2 plus the 3 for a total of 5 observations. Less than 51, so we have 2 plus 3 plus 6, or 11 observations. Less than 62, we have 2 plus 3 plus 6 plus 16, which equals 27. And finally, 2 plus 3 plus 6 plus 16 plus 10 is equal to 37. And finally, 2 plus 3 plus 6 plus 16 plus 10 plus 3 is equal to 40. And that's all our observations. So we're correct. Now, let's build the polygon for the cumulative frequency distribution. So we'll have 2 y-axes. Here we'll have our percentages, and on this side we'll have our frequencies. So on our x-axis, we'll have each of our classes. So less than 29, less than 40, less than 51, less than 62, less than 73, and finally 84 and fewer. So now, again, we can just cut this in half. This will be our 50% point. And let's label the other side as well. Okay, let's start our labels. So less than 29, we have 2 observations. Less than 40, we have 5 observations. Less than 51, we have 11 observations. Less than 62, we have 27 observations. Less than 73, we have 37 observations. And less than 84, we have 40 observations. So we'll just start that there at 0. And here we have our cumulative frequency distribution. So if we had a question like 50% of people spent less than how much at an amusement park, that would be roughly, which is not a perfect estimation, but about $52. Okay, so that was a tutorial on how to go from creating a frequency distribution all the way to generating a cumulative frequency distribution polygon.